Okay, so now that we've seen some examples of sequences, um, what we're most interested in terms of calculus is what happens to a sequence as n goes to infinity. So we say that a sequence converges if the terms approach a single value as n gets larger and larger, and we say that a sequence diverges if the terms go to infinity or they don't approach a single value. So let's take a look at a few examples of converging and diverging sequences. So let's look at the example that the sequence we had previously. The sequence minus 1 to the n times n squared over 2 to the n minus 1. So we calculate a few terms of the sequence, right? So the first value is minus 1, then a2 is equal to 2, then a3 was equal to minus 2.25, and then a4 was equal to 2. So here the numbers don't really approach any number, so let's look at even larger values of n, right? So if we calculate a sub 5, this is equal to minus 1.56, then a sub 6, calculate that, you get 1.125. So here you can see that the numbers are alternating between negative and positive, but you can see that now the values are getting smaller. So let's go even larger, right? So a sub 10, calculate that, see that this is 0.19531. Then a sub 15 is equal to minus 0.0137. So again, the numbers are still alternating between negative and positive. We can see that the values are getting smaller and smaller and smaller. And if we keep going, as n gets larger and larger, so as n approaches infinity, a sub n is getting closer and closer to 0. And so this sequence converges to 0. So this is an example of a converging sequence. Let's take a look at another sequence. So say Bn, say is the sequence cosine of n pi. So when n equals 1, cosine of pi, so b sub 1 equals cosine of pi, which is equal to minus 1. B sub 2 is cosine of 2 pi, which is equal to 1. B3 is cosine 3 pi, is minus 1. B sub 4 is cosine 4 pi is equal to positive 1. So you can see that this will keep continuing. So it goes between minus 1 and 1. Right? So here, because the sequence alternates between minus 1 and 1, it doesn't approach a single value, this sequence diverges. So again, it's alternating between minus 1 and 1 without approaching a unique value. So both these examples are examples of alternating sequences because it alternates between negative and positive. But the first example is an alternating but convergent, and this second example is an alternating but divergent. Okay, so the second sequence diverges because it doesn't approach a unique value. And finally, we'll look at an example of a sequence that diverges because it keeps getting bigger and bigger. Right, so let's take the sequence that we used before. Cn is equal to 1, and then Cn is equal to 3 times Cn minus 1. Right, so we calculated this sequence before. C1 is equal to 1, C2 is equal to 2, C3 is equal to 5, C4 was equal to 14, and C5 was equal to 41. And so you can see that each successive term gets larger and larger. So as n goes to infinity, the terms get larger and larger and larger, so they go to infinity. So this sequence diverges. So we see an example of a sequence that converges, alternating convergent. The second sequence is alternating but divergent, and the last sequence just diverges because the values keep getting larger and larger.